Imagine a world where everything you see, touch and feel is made up of tiny, vibrating strings. These strings are so small that they are completely invisible to us. Yet their vibrations create everything in the universe, from the smallest particles to the largest galaxies. This is the captivating idea behind string theory. String theory is a fascinating area of physics. It attempts to answer some of the biggest questions about our universe. How did the universe begin? What are the fundamental building blocks of matter? String theory offers a new way of thinking about these mysteries. This essay will explore the basic ideas of string theory. We will discuss its history, its promises, and the challenges it faces. Join us as we journey into the heart of string theory and explore the universe's ultimate puzzle. To understand string theory, we need to understand the two pillars of modern physics: quantum mechanics and general relativity. Quantum mechanics describes the world of the very small atoms, subatomic particles, and the forces that govern them. It's a weird and wonderful world where particles can be in multiple places at once and can even tunnel through walls. General relativity, on the other hand, describes the world of the very large stars, galaxies, and the force of gravity. Einstein's theory tells us that gravity is not a force but a curvature in the fabric of space-time. It explains why objects fall to the ground and why planets orbit stars. These two theories are incredibly successful in their respective domains. However, they clash when we try to combine them. This is where string theory comes in. String theory attempts to unify quantum mechanics and general relativity, providing a single framework that can describe the entire universe. String theory proposes a radical idea. The fundamental building blocks of the universe are not point-like particles, but tiny, one-dimensional objects called strings. These strings are incredibly small, much smaller than even atoms. Imagine a single atom. Now imagine that atom being the size of the entire observable universe. That's how small a string is compared to an atom. Just like a guitar string can vibrate at different frequencies to produce different notes, these fundamental strings vibrate in different ways to create different particles. Each vibration mode corresponds to a different particle, with its unique properties like mass and charge. This elegant idea has profound implications for our understanding of the universe. String theory also introduces the concept of extra dimensions. We experience the world in three spatial dimensions: up, down, left, right, forward, backward, and one dimension of time. However, string theory suggests that there might be additional spatial dimensions curled up and hidden from our view. These extra dimensions play a crucial role in the consistency of the theory. Section 4. Imagine these strings vibrating in hidden dimensions. Imagine a garden hose viewed from a distance. It might appear as a one-dimensional object, a line. But if you zoom in close enough, you'll notice that it has a second dimension, a circumference, along which an ant could crawl. Similarly, string theory suggests that our universe might have extra dimensions curled up at a subatomic level, too small for us to see directly. The vibrations of strings in these extra dimensions determine the properties of the particles we observe. Think of it like this: the way a string vibrates in our three large dimensions determines the type of particle it represents: electron, quark, etc. The way it vibrates in the extra dimensions determines the particle's properties, such as its mass and charge. This concept of extra dimensions might seem strange, but it's a natural consequence of trying to unify the laws of physics. It offers a way to reconcile the conflicting descriptions of the universe provided by quantum mechanics and general relativity. Section 5. The string theory, family, superstrings, M-theory, and brains. Over the years, string theory has evolved into a family of related theories. One of the most prominent is superstring theory, which incorporates a concept called supersymmetry. Supersymmetry proposes a deep connection between matter particles like electrons and quarks, and force-carrying particles like photons and gluons. Another development is M-theory, which attempts to unify the different versions of superstring theory into a single framework. M-theory suggests that strings are not the only fundamental objects. It introduces higher dimensional objects called brains, short for membranes. These brains can have various dimensions, from two-dimensional surfaces to higher dimensional entities. Our universe, according to M theory, might be a three-dimensional brain floating in a higher dimensional space. These ideas might seem like science fiction, but they are active areas of research in theory.